In this section, we're going to take a look at a couple of word problems that lead to rational equations. So in the first one, we have a situation where you kayak upstream 12 kilometers and then kayak back, and your round trip takes 4 hours. The current in the river or stream is 4 kilometers per hour. How fast could you paddle without a current? So there's a few assumptions we're making here. One is that you are paddling consistently throughout, both upstream and downstream. And the other is that it's a consistent current. That's actually not a terribly unreasonable assumption. So how are you going to do this? Well, there's one equation you've got to remember that'll help you with these sorts of problems, which is that distance is equal to the rate times time. And you can divide both sides of this equation by r to get distance over rate is equal to time. So we've got 2 trips of 12 kilometers, and in one we're going upstream. So we're traveling the distance 12 kilometers, and when you go upstream, obviously you're not going to be going as fast. You're essentially fighting the current. So however fast you can go, r, that speed gets slowed down by the current, so it's going to be r minus 4. So this brings up an obvious point. Obviously, you've got to be able to paddle faster than 4 kilometers per hour, otherwise you're never going to actually be able to make any progress going upstream. So we know the answer is obviously more than 4. And then downstream, you could just sit back and relax, but we're making the assumption that you're actually paddling at the same rate to head back downstream and not just floating. So we have r plus 4, meaning you're paddling at the same rate relative to the water, and then you're moving along with the whole current at an additional 4 kilometers per hour. And these are times, right? Because they're both distance divided by rate. And so you have a time upstream plus a time downstream is your total time, which is 4 hours. So this is clearly a rational equation, and we can multiply both sides by the common denominator, which is the product of those two factors. So r minus 4, r plus 4. Whoops. R minus 4 and r plus 4. So when we do the product on the left, the first product, the r minus 4's cancel, and we have 12 times r plus 4. And then we have the second product where the r plus 4's cancel, and you have 12 times r minus 4. And then on the right you have 4 times r minus 4, r plus 4, which is a difference of squares, which is r squared minus 16. Alright, if you expand everything, we get 12r plus 48 plus 12r minus 48 is equal to 4r squared minus 64. There's an obvious simplification here. The plus 48 and the minus 48 disappear. We get 24r on the left and 4r squared minus 64. So this is a quadratic. I can subtract the 24r from both sides. I've got a common factor here too, which is going to make my life a lot easier if I want to try to factor this, which is 4. I can take out the common factor of 4 by dividing both sides of the equation by 4, and I end up with r squared minus 6, there's an r in there, r squared minus 6r minus 16, and that factors as r minus 8r plus 2, which means that r is equal to 8 or negative 2. Now, even though negative 2 is a solution to the quadratic equation, that doesn't mean that it's a valid answer. Oftentimes when you get a quadratic resulting from a word problem, you'll end up having to toss out one of the answers because it's just not appropriate. And so it isn't really appropriate to have a rate here of negative 2 kilometers per hour. So we can essentially ignore that one or just eliminate that one, and we end up with a solution here of 8 kilometers per hour. So you can paddle at 8 kilometers per hour. And if we go back and plug that into the equation, it seems perfectly reasonable. 8 minus 4 is 4 kilometers per hour. So when we're paddling upstream, we're actually only making headway at a rate of 4 kilometers per hour. And so it's going to take us 3 hours to paddle upstream. And then when we turn around and paddle back down, we're getting the benefit of the current. So we're actually going 8 plus 4, which is 12 kilometers per hour. And so that's only going to take us an hour to head back down. So the total round trip is going to be 4 hours. All right, let's take a look at a different type of problem, one involving work. So here's the scenario. You can paint a room in 3 hours. You and your sister together can paint a room in 2 hours. So how long would it take your sister alone? Well, the difficult part of these questions is trying to set up an equation, or trying to get a handle on how to set up an equation. So here's how you want to think about it. You want to think about it in terms of your rate of work, just like in the previous one we were talking about rates. So here, what's your rate of work? In other words, how many rooms can you finish in 1 hour? Well, if you can finish a single room in 3 hours, then you can finish a third of a room per hour. Now, your sister. We don't know how long it takes your sister to finish a room on her own. That's what we're trying to find. So let's let that variable be t, which means that she can finish 1 over t of a room per hour. And then together, we were told that you can finish a room in 2 hours, which means that together you can finish a half of a room per hour. So these rates essentially all have to add up. If you and your sister are working alone, we get this equation here. In 1 hour, you're finishing a third of a room. Your sister's finishing 1 over t of a room. And together you're completing 1 over 2, or half of a room. All right, so this is how much work you're doing in a single hour. So that's a straightforward rational equation. There's a common denominator of 6t. So if we multiply both sides of this equation by 6t, on the left, when we multiply 6t by 1/3, we get 2t. Then when you multiply 6t by 1 over t, the t's cancel and you get 6. And then on the right, when you multiply a half by 6t, you get 3t. And that's a pretty straightforward equation to solve. We can subtract 2t from both sides, and we have our answer. T is equal to 6. In other words, your sister alone is going to take 6 hours. Now, at first, this almost seems too much. It seems a little bit counterintuitive. But if you think about it, you know your sister has to be slower than you, because if your sister could also paint a room in 3 hours, then presumably it would take half as long for you to finish a room. In other words, together you could finish a room in an hour and a half. But since it's taking 2 hours, you know your sister has to be slower than you. And so 6 hours, perhaps not unreasonable. It certainly fits the equation. If you go back and plug 6 into the equation, it works fine. 1 over 3, which is how much of the room you can paint in a single hour, plus 1 over 6, how much your sister can paint in an hour, does add up to a half of a room per hour. So for these sorts of problems, it's very helpful to think of amount of work done in a single unit of time, which is otherwise known as your rate of work.